if you understand the fundamental basics of coding, which none of you do. So, okay, you can see this, right?
Yeah.
Okay, someone's mic is giving a bunch of feedback, so just mute if unless you have a question, in which case you can just unmute. Okay, so when it comes down to circuits, the main law you're using is Ohm's law. However, with Ohm's law comes a bunch of different formulas for finding that. Because, okay, hold up, let me just add someone. Um, right. So with Ohm's law, the key is to remember the main formula, which is your V is equal to I times R. If you know that, you are covered for this whole thing. You are covered, right? So obviously, I'm not sure if sir, I believe sir is giving us these formulas, but it's better to know them because if you know them off by heart, you will be able to apply it quicker. And what this means is, if you look at your triangle, V, I, and R, then that's insane, Yukesh. Okay, but anyways, so your V over I times R, right? Meaning to get your resistance, you're just saying V over I is equal to R, and so on. Those formulas are the easy stuff. How you find those numbers is a different story. Because in a circuit, this is something called your V total, your I total, and your R total. Because let's look at series circuits, right? Series first. So in a series circuit, your voltage 1 plus your voltage 2, so on, must equal to your voltage total. Obviously, in the test, you can just write T. I'm writing V total so you guys can understand. So when we're moving to this here, for example, to find your voltage, what it means when it says, for example, V1 is it's asking, okay, at this given point in your circuit, the voltage is whatever it is, right? Now, if, for your amperage, it's even easier because your I total is equal to your I1 is equal to your I2. And what this means is no matter no matter where you measure your amperage on the circuit, it will always read the same amps. Now your resistance is the same as voltage. Your R total is equal to your R1 plus your R2 plus R3 and so on. Meaning if I have three resistors, I add them up and I get the total resistance. Now what this means is if we set up a simple circuit here with a resistor and a multimeter, by setting it up, well, in this case, it doesn't matter because well, this has to do with resistors, but resistors are something we call it has no polarity, okay? Meaning that it allows you to connect it in either direction and it doesn't change the circuit in any meaningful way. So that's just, well, a side note. You don't have to know that. So by setting it up, let's say we have 20 volts and this resistor is 10 ohms. To those of you who do know it, what amperage am I going to get off here? If the voltage is 20 volts and the resistor is 10 ohms, what amperage is this going to show?
Two.
Two.
You
Yeah,
are
in
all
case I got it before you.
okay. Well,
Okay, shut up.
so it will always show two. Well, in this case, don't worry because obviously how the circuit's wired, but it is 2 amps. So Well, obviously, I forgot to change the voltage. There you go, 2 amps, right? And that, so I can see you guys understand it. Sorry, I just have to, let me drag this one on the side here, right? So,
Lisakho, do you understand?
does everyone understand before I move on to the complex calculations?
You understand? Yes. Listen
Uh,
how you saw. Yes, I did. Okay,
uh,
sharp.
okay, right.
Lesego said he doesn't understand.
I might have
What?
to
I'm
redo
so
it just for
sorry.
him. Just remember, if this class goes overtime, I charge the person who made it go overtime.
Hey,
Okay, anyways, so this is your simple circuit. As you can see, it's outputting 20 volts, 2 amps, and your resistor is 10 ohms. So, quite simple stuff. In this case, because it's a series circuit, there's only one pathway. So, obviously, before you even start with your calculations, identify whether it's series or parallel. Now, I've gone over this before, but I'm going to do it again. In a series circuit, you can trace one pathway with your finger. If you put your finger on your screen and you move it from the negative, well, from the positive terminal all the way around through the resistor through here into the other one and back into the power supply. Only one pathway. That's how you know it's series. Now, series circuits, it's simple. You're using these standard formulas here. These ones here. Simple. You guys understand all of those formulas.
yes.
Yes.
Yeah.
Okay, well, I didn't go over it, but I went over how you calculate Ohm's law mainly. But if, let's say, I reconnect this amp meter, and I connect instead of this way, I connect it like this here. According to Ohm's law for a series circuit, what's going to happen? What reading will I get?
No reading.
No, because even though the circuit is technically incomplete, you're still measuring amperage. Amperage in a series circuit, no matter where you measure from, it can be I1, I2, you still get the same amperage. No matter if I take a multimeter, connect it in any 2 points in a series circuit, same amperage will be displayed. That's that formula. Then your voltage total, well, I'm not going to be able to demonstrate it here because that's quite a complex circuit, but your voltage total is determined how you measure your voltage across from the resistor. What this means is you you with a voltmeter you can never wire it in series. You always wire it in parallel. That's something to keep in mind when you measure voltage, right? However, that does not affect how the circuit functions due to the fact that in a parallel circuit the voltage stays the same no matter where you measure it across any branch. So I should probably change this to voltage, right? You can see it's 20 volts. Yes,
I just wanted to ask, man. To calculate your voltage total, you do voltage one plus voltage two plus voltage three, right?
yes,
And then it's the same for resistance.
y-
Resistance one, resistance
yes.
two. Okay. And then current, it's the same.
Current, you saying that the current total is you no
Equals to
matter.
one.
Yeah. You're just saying equals to signs now instead.
Right.
So that's series circuits. Does anyone have a question on any of how these formulas? I'm just breezing through it since we have a lot of stuff to cover. Any of these formulas. Now you're good. Okay. Right. Now we're moving on to the war zone that is known as parallel circuits. Parallel circuits has similar formulas except resistance. Resistance is special. So let's start with your voltage total. Is equal to your voltage 1, is equal to your voltage 2, is equal to your voltage 3, and so on. That means I measure, let's demonstrate this, right? If I build a simple circuit here with two resistors, it doesn't matter where I take the voltage from, it will be the same. So you see, this is a much stronger resistor, a 1 kilo ohm resistor, and this is wired in parallel. Yes, I will also be doing hardware, but I decided to do calculations first. So it doesn't matter. Obviously, there's a small voltage drop due to being two resistors and a high resistance, but we're still getting the same value, even though this is a parallel circuit. Meaning, no matter where I put my voltmeter, where I wire it, I will still get the same voltage. Does everyone understand that formula?
Yes.
That's a good question. I would say that the only reason why I'm doing the calculations first is because the hardware in that you're off by heart and it's mainly you'll get good marks. Calculations you need to physically, it's maths. But I would to answer your question, I don't know honestly. So your amperage then is now I1 plus your I2 plus your I3. And what does this mean? This means if I measure amperage across hardware will slightly be, will definitely be more because that's because there's more hardware concepts to learn than your calculations. But hardware you can just study and you get good marks, like I said. So, so for amperage, doesn't matter which branch, well, your amperage is now split. So if I were to describe a parallel circuit to you, here's how you do it. You say the voltage is shared equally. Doesn't matter. Okay, well, your voltage is the same across each branch. Your amperage is split up, and your resistance, well, that's a complex formula. So, what your amperage, you have to add each branch together. If I get 2 amps here and 1 amp here on this one here, and then 3 amps here, for example, I add them up, I get 4 amps. And that's quite a simple formula. Everyone understands? Okay. Now moving on. This is the form now. Mr. Guy gave us two formulas. I'm only going to be using one because it makes life. Yes?
So when like once we have our amperage total and voltage total, what, all our totals, do we just use the same formula like the triangle?
Yes.
Okay.
So, okay. Now, the resistance formulas, because there's two of them. I'm going to be showing you the one which you can use in any case. Because most of the time, it's going to give us a circuit with three resistors. So you don't need to know both. The formula I'm going to be using is 1 over R total is equal to 1 over R1 plus 1 over R2 and so on. Now what this means is, there's a term in maths, you guys wouldn't have done it, and it's called a reciprocal. What this means is, it's the fraction, it's the inverse of whatever it is. So normally you get your R1, which is over 1. The reciprocal is 1 over R1. So that's just a fun concept. So that's just a concept that's easier, makes us easier to understand, but it's not necessary. What this means is, let's say your resistor 1 is 10 ohms, and your resistance 2 is, let's say, 30 ohms. And you need to remember your calculators for this, just a warning, because I don't want to be doing just maths in my head. 1 over 10,
Oh,
did you need me to lend you a calculator?
yeah, yes, please. Oh,
Okay. Right, 1 over 10 and plus 1 over 30 is equal to 1 over RT. Then, what this means is you just put this in your calculator, 1 over 30 plus 1 over 10 plus 1 over 30, and you get 2 over 15. You are not done now. You are not done yet. Because if you look at this, the R total is inverted. It's under one. It's 1 over the R total, which we don't like. We want a whole number. Yes.
When we asked Mr. Guy today for the class, he said that we must find, like, we asked about this, like, exact thing, and he said we must find the LCD between the two. So, like, we would times, right now, we would times 10 with 3 and 1 with 3.
Yeah. So he told us the same thing, but we allowed calculators, right? You know what that means?
Yeah.
You don't need LCD
He also said that
because
we must, like, show all our calculations and everything.
okay, but so you guys are old enough to be able to understand this, right? I'm just using a calculator for the purpose of this. Because once
Okay.
you simplify it, it's going to give you 2 over 15. Am I right? Even if, because if I do the LCD here, which is then 30, I'm going to get 3 plus 4 over 30, which is then equal to, well, 3, no, not 3 plus 4, but 3 plus 1 over 30, which is equal to then 2 over 15.
Nah, someone stole my calculator.
Yes? Yeah. Catch your ends up.
I think his mic isn't working.
Oh, yeah. Yeah, okay. Um, well, what's your question? You can hear me, so just put your question in the chat. Okay. Anyways, how do you get negative 1 over 10? Where are you seeing this exactly? Yeah. Oh, my bad. That's my bad. Because I'm writing with my mouse. Don't worry about that. So, yeah, I'm fine. Anyways, so you do get the same thing. So if he said that because he's the teacher, he set the paper, so then in any case, show you're working out, but when you simplify it, you get 2 over 15. Now the question is, what do you do from here? You getting a fraction, 2 over 15, but that's not the resistance total. That's equal to 1 over the resistance total. Meaning, you need to flip the fraction around. Because when you flip it, you get R total over 1. We want R total. We don't want R total as a denominator. So when you flip this side, what you do to the one side, you to do the other. 15 over 2, and that's 7.5 ohms. Now, how do you check your answer? What you do is, you'll see, okay, the smallest one is 10 ohms here, and our current one is 7.5. That's how you know, okay, my resistance total will always be less than the largest one. Yes?
Do you have to like check your answer?
I'm just saying that just in case you messed up somewhere or if you forgot a value. You're
Alright,
not
bet.
getting marks for showing me, for checking it. Kian, you're still there. Is your hand still up? Do you still have a question?
Oh, nah. Let me take it off.
Okay. Right. So now you see, okay, your answer is here, and that's it for your resistance formula. Does everyone understand how to use this formula? You just raise your hand if you don't, then I'll move on. Okay, we're all good then. Now, that's basically all the calculations covered. So now, do you want to move on to the hard way or do you want to go and study? Because I'm gonna be on.
Hard
Well,
way.
I'm gonna have to cut it at like around half past and start a new one.
That's fine, Big P.
Okay, right. Everyone understands this hardware. Okay, right, hardware.
Yes.
Yes, hardware, please, Big P.
Now, the thing with hardware is there's barely anything for me to explain. If you study, you will understand more than anything, but I'm gonna go through it anyways. Do you, so from which page does anyone have your booklets in front of you? Do you guys have your booklets in front of you?
No.
Nah. Okay. Do you guys want me to do breadboard or what is robotics?
What is robotics?
Can you
Nah,
like start
Red
like
Bull,
from
bro.
the
Robotics.
very start
Must
so
I,
we just know?
must I start?
Robotics.
Okay, I'll start
Mm,
from the very start. What is hold up, I'm just getting a
Oh,
call quickly.
decline.
Oh yes. I I forgot to send the link to half the people. Just give me a minute. Said I must upload the link on here quickly. What if I don't allow Tian on the call? I say we take a vote. Do we deny him or admit him?
what's he gonna do?
He's also being tutored. Okay, I won't mess around, right? Okay. Anyways, the hardware side. Now you just need to know robotics. What's it about? Engineering, computer science, technology, essentially STEM, and you build robots. So robotics is about building robots using STEM, right? Now,
What's the
STEM is science, technology, engineering, mathematics.
no?
It's the abbreviation for the field. Now, they either perform tasks autonomously or semi-autonomous. Autonomously, right? Meaning, I could have, for example, a system that turns on my lights at a specific time. I know a few parents may do this when they go on holidays and have it on a timer. That is autonomously. It requires no human input once set up, meaning it will go on every day at, for example, 8 o'clock at night, those lights turn on or off and turn on or off at 3. That's autonomously. Semi autonomously means that I need to physically do something. For example, turn on a switch, press a button, interact with the machine for the task to be completed. Autonomous things you would find in mainly your Facebook, Instagram, for example. Say the messages, uh, without needing a human, once you input it, they get sent to the person, or once you repost a video, they automatically done that on the server. There's no human interacting with the server itself. Semi-autonomously, think of it as you pressing a button on your garage remote and it opens your garage. Even though it's being done, instead of you manually opening the garage, it's still being done by a robot in the sense. Okay? That's essentially what robotics about. The key components, the mechanical systems, sensors, and controls. Mechanical systems, they move the robot. How does the robot physically move? For example, it can move with motors or it picks up something. Then sensors, how does the robot know its surroundings? A sensor can be a, for example, an LDR. Yes.
Did you guys get sensors for your like study notes?
So it's under the key components of robotics.
Because for us, Sir said we don't need to know like the key components of robotics. We just need to know the names.
No, he said the same thing for us.
Or
Oh,
am I just tweaking out then?
No, he said you must know how to tell if it's a sense or something like that.
for
Not like
us, for us, Sir said, name. If he had to ask us what are the key, like he would ask us what are the key components of robotics, then he said we should just know the three. Then like the same thing for the types of robots. He said we must just know like the
Just
main.
know it, not be able to explain it.
Yeah.
For us, he said we have to know the types of sensors, I think.
yeah, we just
No,
need
no,
to
no,
know
no.
this.
You thinking types of sensors as in the LDR and whatnot. We talking about the sensors as in On the
The
Oh,
first
like
page, the
robotics
robotics.
physical,
robotics.
Oh,
yes, that what is robotics all about?
oh,
That's what we're talking about.
You can
oh.
even ask Yukesh, like he just said we must know the names of it. So like
Um,
humanoid,
oh,
mechanical
okay, okay,
system, all that.
No, look, you just said know the types.
okay. So you just need to know basically the three main components of
What are the three?
robotics. I'm asking just to make sure.
Oh,
So it's the senses and perception, whatever perception.
Perception,
Then
The
your
control
mechanical
systems also
system, and
the
then control
mechanical.
system.
yeah, okay. So you just need to know them. Don't
Yeah.
have to
so
be
it's
able
what?
to.
Senses and perception.
Mechanical systems and control systems.
Yeah.
And then it's the same thing for the types of robots, like your humanoid,
Okay,
your
well, the types and that is just common knowledge. You can say industrial. A robot
yeah.
used. A robot made my car like that.
So do you guys
Wait.
gonna ask us to explain what each and everything is?
No.
Yeah, and
Okay.
did Sir tell you to study an introduction to
DP.
the Arduino controller thing?
It's pretty much for the Arduino thing. He just said, let me go to it quickly.
The key
He
components.
just said we must know like the first one of the introduction,
You mean
number
the
one.
80 mega 328p or something like that?
Yeah, he said we must just know the 80 mega and it's like extensively utilized.
Oh,
Just
okay.
that. But Johnny also highlighted number two. So maybe
Oh,
also learn number two in case.
Wait,
okay.
what color is it highlighted with? Because where are you
Let
getting
me
notes?
let me check the thing quick. Uh
Because I
it's
feel like I saw someone's notes with it
Maybe.
highlighted.
it's
So do you understand?
highlighted in, so the first one's highlighted in pink and the second one's highlighted in two. I mean
Okay.
in
Yeah, no,
orange.
I haven't seen those. Okay. But I think that's just Johnny being Johnny. So I'll breeze over that, but don't worry about it. So I think I've wasted enough time now, obviously with my fault not getting the message correctly, but anyways.
If
So
you like, if you like make a mistake, like you explain something, you should. I'll just say like,
yeah,
uh,
just tell me because
alright.
I'm not 100% sure. The types, that's common knowledge. The applications, that's easy stuff. The future of robotics, I don't think you need to know.
Now we don't need to know that.
Okay, okay.
For us, we don't even need to know the applications.
Yeah,
Which applications?
the applications of robotics.
Yeah, for us, sir didn't say
Oh
anything
yeah,
about
yeah, yeah.
that.
Nah, you didn't say we must learn that one.
So,
Alright.
yeah, and can you please send me like the what you guys need to learn? Because different to ours.
Do you want me to send it to, like, do you guys have a group for this? Then I can send
Yeah,
it to you.
we have a 9A group.
Must I send it to? Okay, I'll send it to you. Then you send it to them. I'll send you
Okay,
Johnny's first.
Okay, thank you.
okay. So that's also my fault for not getting the message. But anyways, so I think I'm just gonna move on to the breadboard. Now the breadboard is quite simple because it's a rectangle, and all it is a fancy wire board. What it allows for, so there's two types of strips here, right? Who can tell me what the two are?
Bus and terminal.
Can you identify which one here? So the
What?
one that I'm pointing out right now, which is it?
Bus troops.
Yes, this is
Bus.
your bus strips.
Yes, yes. I
And
That's
the
said it
middle
before.
one,
and then these ones are
Terminus troops. I
terminal
said it before you
strips.
guys.
okay. In the competition, what you want to sweet for it?
Yeah, simply. Yeah, yeah.
Okay.
Right. Now, how it's connected is there's a small copper plate at the bottom. That's just for your own. That's how you know it's connected. Now, what is a bus strip used for? Generally, you connect a 5-volt power rail to it on this one, or and a ground here. It depends on what it's labeled because it will be labeled positive and minus, so dependent on that. So the bus strips is your power source, right? Meaning you're connecting a 5-volt to it, a ground to it, right? Your terminal strips are where you place the actual components. So, for example, as I said yesterday, there's two ways, yes.
I just wanted to ask, what's VCC?
VCC is voltage control circuit.
Okay.
It's just power delivery. Remember it as that. Wait, I'm not exactly sure. Let me see. VCC meaning. I would assume it's just voltage something. Voltage common collector, but you guys don't need to know that. Anyways, so what does where you connect now? How do you connect it? Because in the last paper, so I asked the question where he said, see, connect an LED and a power source to this, for example. Now, there's two ways you can do this. For example, let's say I have a resistor and I want to connect it without it shorting. Because electricity takes the shortest path, the path of least resistance. Meaning, I would draw it like this here, there, or like this here. The current is inversely, no, it's inversely proportional to the resistance, not voltage, you guess. So there's two ways I can do it. I can connect it like this, or like this, with it bridging. But if I connect it like this here, across one strip, it's not going to work. And we can actually see this here in Tinkercad. So I have a resistor here. Um, I have a resistor here. Here's this one way I said you can connect it, and here's the other way. Both of these are correct. You'll see that if I connect this up to a circuit, it will work. Just excuse the wiring. Now, obviously, the proper way to do it is you connect your positive to your positive rail here. I call them a rail. The proper, well, you can use terminal. Terminal is the preferred word in this case, but I just say rail. You connect your 5 volts here, and you can see, okay, I can take it off here, or end off here, and this will work as long as I plug this in. Obviously, this is supposed to be red. This must be black, right? Now, if I try and connect this up, will this work? Based on what I've explained, will this circuit work?
Yes.
Yes. And you can see, you can see that obviously the one hasn't been connected, but anyway, you can see that it will work. And if let's say I take away this resistor, will it still work? No. You know why? Because what are the two terminals connected to? My bus strip. The bus strip is one unified strip, meaning no matter where I take from it, it's still the same point. What this resistor is doing is it's just bridging this gap here. The correct way to do it is you have to power it like this here. So let's see what happens if I press start. The voltage meter reads 0. Because why? Look at the circuit here. I'm connecting the positive terminal to here obviously. But is this side connected to anything else? No. Meaning the circuit is broken. You can see here, here's the resistor. It's making a complete circuit, yes, but the actual power source is not completed. Meaning if I connect it like this here, circuit should in theory work. That's how you know. Hey, why are you spamming here now? Katishu, do you have something to say?
No,
I thought so.
nah. I said no because it didn't work, bro.
Yeah, you're a bit delayed.
Nah, bro, trust.
Okay, anyways, that's the breadboard. What are the advantages? Can anyone list all four?
I can.
Okay, go for it.
Same, same,
um,
same, same, same.
Go
okay,
to
I'll
two.
do you list too, ne?
I go.
Uh, it's educational, like it's great for learning about electronics.
Yes.
It doesn't like need soldering, meaning like you could reuse the components and like connect and
Yes, yes,
like
yes.
take them out easily.
And then it also has the prototyping and the flexibility.
Okay. Are you guys very good at reading?
Yes, 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 yes.
Yeah, I knew that. At least you can read. That's something. It's a skill everyone should have. But anyways, the tips we don't need to know. Common breadboard layout I just went over. Right, the Arduino controller. Right. You said that the first two lines. Okay, I'm just going to do the first two lines because that's the most important two lines.
So I we only did number one, but Johnny also did number two.
Well,
So I just assume number two as well.
yeah, because and also it's short, right? So
Yeah.
let's say I go on to Tinkercad and I drop an Arduino, right? I'm gonna well, many of you don't understand computing that very well, but who can tell me, Dilo, if you don't answer this, I'll be disappointed. What component this is? Exact, letter for letter.
Yes, come on, below.
It's a microcontroller.
Okay, and what model is it? What model of
It's a
microcontroller?
Mega 328p.
What
Lebo
generation of Uno is
Mafilela.
this?
Huh?
What generation of Uno is this if it's an 18 mega 3828p?
Big P must we know this?
Yes.
Wow. I don't know.
A, a revision 3.
Oh. So
Okay,
that's what the R3 means.
yes, revision 3. Right? So that's in essence what it is. The 80 mega 328p is the main brains. To those of you who have built PCs, it's basically a CPU. And for the Arduino Uno R3, obviously you can buy this part individually and you can program it. However, that's more difficult than actually using the physical board. Now, this device specifically has 14 digital pins, as you can see here, from 0 to 13. Digital meaning it either outputs 0 or 1. Input and output 0 and 1. Now, my Arduino is not here today, so I can't show you. Well, it's in one of my projects, but anyways. But this pin can output a 0 or 1 or input, take an input of a 0 or 1. That's what digital input to output means, right? Now, six of them, you see the squiggly line here. 3, 5, 3, 5, 6, 9, 11, 10, and 11. Those squiggly lines means pulse width modulation. As you can see here, it says digital PWM. Now, I'm not going to explain what pulse width modulation is because it's not required, but just remember those specific pins are PWM pins, right? Then obviously you get your power input and output, your grounds, simple stuff. And at what speed does this operate at? It's in megahertz.
16.
Yes, 16 megahertz. Okay. Can anyone tell me what ICSP stands for? Okay, I'm assuming no. Bilo,
What's
you
the
should know
question?
this, right? What does ICSP stand for? The header. The ICSP header. In circuit serial programming. What this means is instead of plugging in this board here with this USB cable, I can attach my pins here, a few pins, and control this microcontroller directly instead of programming with your Arduino IDE. That's all you need to know in this case. So for direct programming, and a reset button, that's self-explanatory. I went over the key features, right? The analog pins here can return a value of 0 through 255 or something like that, dependent on what's connected to it. So, for example, If you have a temperature sensor, based on what I've told you, which pins are you connecting it to? You need one for power. A temperature sensor has three pins. One for power, one for ground, and a third one. The third one is where the data goes in and out. In this case, out. Which pin am I connecting it to?
Uh,
Take a
Like
guess.
the analog.
Yes, the
Analog.
analog pins. Okay, right. So it's the yes. So it's the analog pins because they can take a large value of numbers. Then you don't need to know the starter kit, resistor. I went over this yesterday. Do you guys want me to do it again?
Nah, it's okay.
Resistor, you guys are good. Okay.
I see. Hey, how?
I
Ah,
suka wa.
Okay, the call is going to end in 15 minutes. I'm going to create a new one and we'll just move now.
thank you, BP.
Okay, so decide.
Wait,
We'll take a vote. Yes.
what does the ICSP mean again? I forgot to write it down, bro.
In circuit serial programming.
Um,
No, wait,
Do we
in
need to vote?
circuits. Well, yeah. Wait, let me just make sure I said it right. In circuit serial programming. Yeah, I was right.
you guys also got the key components, ne? Like
Yeah,
just the names.
yes.
Almost the guy crashed out in the middle while he was giving our demarcation.
Yeah. At this point, can't even do anything. Okay, so let's take a vote. Raise your hand if you want me to do resistors again. Okay, let's see. One hand.
Maybe just the definition of it.
Okay, there's the new one. We'll switch over when we need to. Right, so the definition of a resistor, quite simple, right? It's a component used to limit the flow of electrical current in a circuit. Like Mr. Waller said, it can be your speed bumps, right, in your circuit. What it does is it slows down. So your voltage is how hard the current can push. Your current is how fast the current is. The electricity is moving. So by putting a resistor, we're slowing the whole circuit down. The slower the thing goes, the less likely your compo- components are to blow up. That's the function of a resistor. Where you use it, it's used all around in any circuit you'll find in a resistor. The color coding must I go over? Do I need to go over the color coding? Yes. No. Okay, below we know you know your work. Relax.
Wait,
Okay.
Pamir,
Yes.
for the color coding, when we get our final answer, like, do we have to convert it to kilo ohms or can we leave it in
Now you can leave it in
normal?
ohms.
Okay, thank you.
Okay, right. I I have to move over now. So I sent the link in the chat. Just join there. I'll wait. I'll wait for everyone to move over. Yes, Isaiah.
My fault, man. Still, my bad.
Nice, right? Okay, I'm just waiting for everyone to move over to the new link.
Yes, let's say move over.
Yeah, oh.
It's in
Where?
the chat. It's in the chat.
I don't think I'm in the group.
No, I am not in there.
Oh, shit, my
It's
bad.
on the.
Slow good.
Oh, damn.
Charlie.
There's still a few people in the old
Yo, this is
meeting
the wrong thing. You.
there.
Wait, where's the new link?
It's in them. It's in the chat.
Our 9A group.
No, 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 no. In the Google class, in the Google chat, the Google Meet
Okay,
chat.
thank you.
Yo, this guy can't be serious.
But wait, I can only see the.
Did I join the right time?
Oh,
It keeps taking me
Pravir.
back to this one.
Also, me.
Masan,
Yo, Mats.
are you sure you? Okay, there. I see. I see. Maybe must I just hang up the call and then put it in the chat of the
Yes,
9A
please.
group? Because I see that who's left in this one. Yeah.
Also send to me, please.
Yes. Okay. Here is the new link, and yeah.
Pravir.
Yes.
Um, like is the potentiometer whatever like is that also confusing for you or is it like easy?
Okay, but I don't think it's fair comparing what's confusing for me and what's easy for me because I've worked with electronics before this.
Okay, okay. Can you
So,
like explain that? Because like I don't understand. Because I know it has three terminals, like the track, the resistive track, and then the slider slash like wiper. But I like don't understand. And it's like a voltage divider and then the variable resistor. But I don't understand like how it works.
okay, that I'll explain to you now. Is everyone moved over? I would assume so. So,
Oh,
I'm
no.
just right. So with the resistor color coding chart, sir will be giving it to us, so you guys can be happy, right? Now, let let's pull up an image from online here, and I obviously have the table in front of me, and we'll identify it. Right. Let's look at this one here. It's a four-band resistor. Um, Yukesh, can you give me the? Do you have the booklet in front of you? Okay, okay. Who can tell me who has the uh, image in front of them with the color coding?
Yeah,
Does anyone have? You have it in front of you.
yeah.
Okay. Tell me what's the resistance of this resistor that I have here.
So is that brown? The
Yeah,
first one.
that's so brown, red, black, and gold.
Okay, so the first band is the first digit, so it's one. Red is two,
Yes.
and then black's multiplier is 10 or one.
Yeah.
Um, and the tolerance for gold is plus minus 5%. So it's gonna be 120 ohms plus minus 5%.
You are close
Ish.
because black. You see the multiplier for black. It's 10 to the power 0. Anything to the power 0, you're timesing. In this case, you're timesing it by 1. So
So
you
it would
already
be
have
12.
12 ohms.
Okay.
Okay, let's look at these ones here. There's multiple examples in this case. Who can tell me the first one here? That's yellow, violet, orange, and gold. Okay, wait. I'll put.
Okay, do you want to know the digit or the multiplier?
What's wrong?
Do you want to know the digit or the multiplier of
I
the?
want to know what's the resistance. I'll put it I'll put it up for you guys here now, so it's easier. Cause I know half of you guys don't have your things here next to you.
I want to ask, ne, when we write the multiplier, let's say the multiplier is black. Will we just write times 10 to the power of 0?
Yeah.
Okay.
Is this
Should
large
write it
enough?
like Mr. Wallace gave us.
No, because then that's technology. Technology. So look, let me explain something to you guys. Technology has no standard to everyday life. I'm telling you now. The things we do in tech, the symbols are completely different to what a standard electrician uses.
Mhm.
The principles that you use in technology are completely different. That's why so when we do circuits, I generally ask, so I asked Mr. Walia if we can use our symbols that Mr. Guy gave us, and he said yes, that's fine. So it's easier to use robotics standards because robotics is a standard. You can go into the outside world as an electrician. If you learned it from your robotics, you'll be fine. With technology, it's something else. That's my only warning. So I wouldn't be studying with your technology booklet. In fact, what you're learning in technology, throw away all that.
No, I'm just saying like only this thing that you're showing now. Because of course we can.
That's missing a few of the values.
Uh,
Quite a few of the tolerance values also. That's originally the table's correct. It's just missing like the smaller tolerance values.
okay.
Okay, right. Now I have it here. Tell me for this one, what is my resistance value? Let me pick a random person. Tian. Tell me
Um,
what is my resistance value. That means what's my number in ohms and what's my tolerance.
it would be 4, 7. The multiplier is 1 times by 1k. And is that gold?
Yeah, that's gold.
Okay, and then a 5% tolerance.
And that's correct. That's correct. Right. Now, for the next one, you need to be careful because it's reversed. You'll see that, yes, there's still four bands, but where's my gold value? It's on the other side. So who can tell me what's going on here? What's my ohm value? Let's pick a random person. Um, okay.
Big P, bro, is it like the multiplier?
So you see how Tian gave the answer, right? He gave it
Yeah,
to me like this here, where he said digit one, digit two, then he told me the multiplier and the
yeah.
tolerance. And obviously, once you work out the multiplier, and that you give me the ohms at the end of your answer. So can you tell me, wow, what's my ohm value and what's my tolerance? That's what I'm asking. Okay, are you guys completely lost for this one because it's mirrored? Yes, Yukesh?
Is it not like two, and then 2 zeros, ohms plus minus 5%?
Yes, right. Now, when you look at a resistor, you'll see that the one band, if you're starting with gold, you know your resistor is inverted. I don't think you'll give us inverted examples, so I wouldn't worry too much, but you are correct. Okay, do you guys understand how to do this table now?
No.
No.
Yes.
Okay, tell me
So,
which part, which is not even on the call. Which part of this don't you understand? Cat, you said you
Cause
don't
like
understand.
when like when you're supposed to get your ohms, like how do you get it? Like from the thing.
From your table.
Yeah.
Right. So let me explain. Let me do one example with you, right? Let's do this one here, right? So I see it's yellow, meaning it's a digit of four, right? So let me explain. It's a four band resistor, right? Your first two bands are your digits. Don't worry in this one because, right? And then your third one is your multiplier, and the fourth one is your tolerance. So what's my? So I see I have a yellow here. What number am I putting for yellow?
4.
Right? Now I'm going on to my second band. What number am I putting?
7.
Now I'm moving on to my third band. What's going on with my third band?
It's 0.
You timesing by?
Oh, times
Timesing by what?
1.
Yes. Then, for my fourth band, what's happening? My tolerance. What's my tolerance percentage?
Uh, plus minus 5 is gold.
That is gold.
Wouldn't it be plus minus 5?
Yep, you are correct. Now, this is you don't leave your answer like this. You
Stats.
just have to say times. So you say 47 times 1, which is,
47.
are you sure?
47 times 1. Yes.
Just making sure.
Hey.
You never know.
Nah, bro. Trust, bro.
That's your answer, and that is correct.
Oh. Okay, bit. So on the third band, you multiply.
Yes,
So the first two are your
digits, the numbers are actual numbers.
okay, then the next two are your multi I mean the third band is your multiplier, and then your fourth one's your tolerance.
Yes, exactly.
Oh, okay, good. I was
Right, can we move on now? Do we finally understand this? Right.
yes, big P.
The diode is the an LED. So I'm gonna go over up till the pot, up till the LDR. After that, you guys can study the other one, the sound sensor, because that's easy. And I did everything else, and then we're done. Right, doing the diode. Who can tell me what's the function of a diode? Yes,
Um, isn't the function to like allow current to only flow in one direction,
spot
like
on.
a almost
That's
like a switch?
yeah. Well, not really a switch. A switch controls the flow of current. This just allows it in one direction. Okay, right. The thing with the diode is this is the symbol. Obviously, you have to fill this in properly. I'm not going to do that. It has two terminals. How do you know which is which? Using your normal current,
Oh,
which way does the electricity flow from? Positive to negative or negative to
yes,
positive?
Positive to negative.
So
positive
when
to
I'm filling this in, I have an arrow in front of me. So which is my positive terminal and which is my negative terminal?
The one behind the arrow is positive, and the one in front is negative.
yes,
Yes.
yeah.
Are
Isn't
Oh,
the
you
one? No, man.
okay? Right. That means you see this line here, right? When the actual component in real life has a line there that shows the negative terminal. That's just something to take note of. Right. Which way? So now we know that the current flows in this direction, right?
mhm.
So we get that's where we introduce bias. Now with bias, it's simple. You get two types: forward and
Backwards,
reverse.
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 bro. I
It's fine. You're close enough. No, I'm joking. Remember it as reverse. On your car, do you say you go backwards? You say you put it in reverse gear,
yes.
right? Now, how does each one work? With forward bias, my positive terminal of my battery is connected to my positive terminal of my LDR, meaning that positive has a higher voltage, right? Because what voltage does ground have? If one of you gets this right, I will be impressed with you guys. What
69.
5.
what voltage does ground have when it's not connected in a
Okay.
circuit?
When it's what?
When it's not connected in a circuit, what voltage will
Zero.
ground have? Yes,
0.
Zero.
yes, right.
Yes.
Meaning, and your positive will have it will have however many the battery is. It's based on the power source in that case, right? So with a forward bias, your positive has a higher voltage, right, than your negative. Because you're connecting positive to positive. The positive side has more voltage, negative side less voltage. When this side is higher, the current can flow. Remember, think of it like this. You all know your greater than and less than signs, right? When current, when this side is higher, we say this is greater than, right? Meaning, and which direction is this arrow going in? It's from left to right, left to right. That's how you remember it. You see that, okay, this arrow is going this way. It follows my diode. If it's this way, you'll see it's the other way. It's not going to flow because current wants to flow this way, and we know that's not allowed. So with a forward bias, your positive side has more voltage than your negative side, which allows current to flow. In a reverse, it's the exact opposite. It's a negative has a higher voltage, and your positive has a lower voltage. And who can tell me what happens?
Um, the current won't flow.
Yes, right. Key thing to note, because of the materials used in a diode, you do have a small voltage drop of 0.3 volts. Just that I that is somewhere there. Yeah, it is there in your forward bias. But obviously I'm giving you summaries. So
How do you say that word? Germanium, whatever that thing is.
German that German no, I'm not gonna try and pronounce that. Bilo, you spamming emojis. Let's hear you try and pronounce it.
I can't. I'm sorry.
I thought so. Right,
Ventile.
I told you.
right. Don't worry about that.
Sugar.
Just remember that the newer ones have a this less voltage drop. Right. Do you all understand diodes and how they work?
Yes.
Right. Now, where do we use diodes? Who can tell me?
In protecting a circuit.
And
I don't know.
Light emission.
you thinking of a light emitting diode. I'm talking about a normal diode.
TV.
Rectification.
Yes. Rectification of what?
In
You
part
guys are
of alternating current.
to DC.
Yeah. Wait, it's converting alternating
Is
current
that in our
into
study manual?
direct current.
What's wrong? Yeah.
Did you guys get that? The basic functions of a diode, key
Yeah.
function.
Did you guys not get that?
Now we did.
Okay.
You might be lost.
Hey, take 12, bro.
Okay, so why it basically allows from AC to DC. Yeah, protection, for example, let's say I accidentally blow a plug. It won't allow the voltage to be sent back into my appliances as long as it has a diode. Simple stuff like that. Light emission, obviously, that's an LED specifically. Be careful. A normal diode does not emit light. Now, the LED. LED is simple. It's the same thing as a diode, except you draw two arrows here. Simple. And what does an LED? It's in the name, light emitting diode. It's a diode that emits light. Simple. Can emit different light spectrums. And how it works is the same. The same bias still applies to this because it's a diode. Where is it used? It's very efficient compared to your normal light bulb. Keep that in mind. Lighting displays, your screen you're looking at right now is made up of millions of LEDs in many signage, billboards, traffic lights, communication. Your TV remote send signals to your TV using an infrared light. Now, does everyone understand LED?
Yes, PP.
Right. Now, potentiometer. Here, and this is where I'm coming in now. Right. So, with the potentiometer, it's a potentiometer is what an LED is to a normal diode. Also, a similar form of it. The thing with the potentiometer is, in a resistor, the resistance is determined when it's manufactured. However, in a potentiometer, I can change the resistance. Where, who can give me the most common example? There's two of them in which you use a potentiometer. Yes.
Is it? Wait, please repeat.
Where is it? Well, you can give one of the two most common places where you can use, well, where a potentiometer is used.
Like volume control.
Yes, so in your speaker systems. Now, how does it work? There's a, this is a wiper, and when you physically turn the dial or move the thing around, this thing physically moves and changes the resistance. Remember what I said about earlier? Electricity takes the path of least resistance. Meaning, let's say instead I put it here, it's going to have less resistance by traveling there instead of by doing that there. Meaning, I can control the resistance now. So a potentiometer has three terminals instead of a resistor which has two, and it's a variable resistor. Variable meaning it doesn't have a set value, right? It can adjust the volume or the current in a circuit, right? Controls brightness, whatever. Um, we only have to do the applications. We don't have to know how a potentiometer works. Right? Did you have that in your booklet?
No.
Okay, right. The applications. We've already gone through one of them. The second one, brightness control. If you have fancy lights, you have a slider or a knob on it that you can change the darkness, the brightness of your bulbs in your house. That's that's the second one. Your speed control in your motor controllers to change the speed. If it's spinning too fast, you can adjust it with your variable resistor. Calibration to fine tune settings, position sensing in joysticks. Now, I gave this example yesterday, I'm going to give it again. In a controller, you have two joysticks. Well, the most common controllers, you have two joysticks, right? And inside a joystick, you can move this joystick in four directions, like this here, right? In a joystick, you have two potentiometers working together to determine the x and the y axis of your position. So when you move that, you're moving a potentiometer inside. You know stick drift. Many of you guys have encountered stick drift. Am I correct?
Yes,
Right?
especially Kunachi.
That means you're moving it around way too much. Because it's a physical component that moves around, it wears out over time. And when it wears out, it's wearing out the resistive material, meaning it starts malfunctioning, right? So obviously it does have a limited lifespan because it's a mechanical resistor. So that's it for the resistor, no buzzer. Tilt switch. In the name tilt switch, basic function. It detects angle of position. Simple. Would you guys want me to go through it in depth or can I just skip over it? In depth. Okay. If you want, put up your hand if you want me to go over it. Okay. I'll go over it then. So how it works is it either has a ball or liquid mercury inside. When you tilt that, that bridges the connections between two electrical components, right? you see it has two pins. Those pins are normally not connected, but the minute I tilt it in a certain direction, that ball or liquid closes the gap, meaning it then opens the circuit. So it allows the circuit to the flow. Okay. Anyways, where it's used is we don't have to go the LDR. Now, an LDR is also a form of resistor. The LDR symbol is, I'm pretty sure it's this one here, right? So it's a normal resistor with a circle that then goes in here like that. Now, what this means is it changes its resistance. It's also a variable resistor. However, it's also known as a photoresistor because it changes resistance based on how much light it's exposed to. Now, how it works, light is made up, the light you're seeing right now is made up of something we call photons. Photons have no mass, and the speed of light is 300,000, whatever. Don't need to know that for now. When you have a very bright light next to an LDR, there's a lot of photons coming into it, meaning there's small holes inside here. Then the photons close the gap inside there, meaning there's very little resistance because there's many pathways for electricity. But in a dark area, you will see very little light. So there's more resistance because there's less pathways for electricity to flow. That's how it works. In application, your automatic lighting systems that turn on when it's dark, your street lights, for example, the light sensors, your smartphone, when, for example, you're in a dark environment and it decreases the light or it increases based on the settings you have. In a professional camera, it does have, in a professional camera, it does have LDRs to determine your flash and exposure and some choice. Right. Push button, you don't need to know. Sound sensor. It's a microphone in essence because what it does is detects sound waves, converts that to a signal that your Arduino can measure. So sound waves, output when you talk or when I'm talking right now, my mic is detecting the sound or vibrations in the air, and converts it to an electrical signal that is being delivered. Now, the way it works, it's in your mics, your home automation, for example, Alexa, Siri, security systems, some interactive toys, and that's your sound sensor. Nothing of the seven segment, not the obstacle, and then the introduction to Ohm's law, and we're back where we started. Yes, Kian.
I just wanted to say, Nim, with the potentiometer, we need to know how it works and its basic functions, eh?
So, did I miss anything when it came to that?
Yeah, you missed how it works, like with the voltage divider, the variable resistor, and then yeah, that's pretty much it.
Okay, so excuse me, when the voltage divider mode. So when you connect three terminals here, when all three terminals are connected to a wire, you get something called voltage divider mode. And what this does is when you turn the knob, the input is divided across these two. This one and this one here. Let's say this is your input here. Doesn't matter which is your input and your output on the terminals. This is your input. You input, let's say 5 volts. And I turn this thing, it splits, let's say 2 volts here and 3 volts here, depending on the position where, obviously, the wiper. Um, yeah, that's about it. Well, it doesn't split, it splits it evenly, but how much voltage is outputted is based on the wire, on the wiper. Then you get something called voltage divider mode. Well, we did voltage divider mode. Variable resistor mode. Now, this is how commonly speakers are wired. When only two terminals. For example, this one and obviously the variable wiper here. Now, when it's connected this, it functions as a resistor, where you can change the resistance. If I supply 5 volts there and 2 amps, and my resistance is 220 ohms, whatever, right? It's a resistor where instead of having a set ohms, number of ohms, you can make it larger or smaller based on where the wiper is. Did I explain that? That's everything I missed that section, right? Okay. Then that's it, I believe. We went through Ohm's law. Um, we went through all the calculations. So we are done then. Any questions? Because obviously some people missed a few things.
No, I
I
don't have
will.
any questions.
Okay. Got everything before I go. Okay, wait. Before I go, who can tell me what's the formula for calculating resistance in a parallel circuit? Let me ask a few questions.
No.
Okay, Isaiah. Kian, you're answering too many
So you
questions.
have to say R total, no, 1 over, yeah, 1 over R total is equals to 1 over R1 plus 1 over R2.
And so on. Just remember, it's dependent on how many resistors you have, of course.
Yeah, yeah,
Right.
yeah.
Um.
This
Yes.
for series.
Parallel.
Now for parallel.
Okay, bet.
I have it somewhere here in the document. Yeah. I don't know if you can barely read it. Just excuse that. But it's just the general formula here. Here is the formula block. Yeah. This whole block here. Here's the series and then the parallel. So if you have any questions, just ask me to see where on the notes you have a question because did quite a bit. Okay, if you good, you can log off. You can leave, and I'll give you yes.
Um, I just wanted to like ask if you could give like an example of like the calculations. Like, let's say it's like a parallel circuit, and then Sir gives us the values of two resistors, but then he asks us find the other one. How would we like do that?
Okay, right. Now you first take your okay. Give me two random numbers to put input there. Well, actually, you need three. The odd Okay, wait. Let's set it up like this here. I'm gonna supply you the I values. Well, you must give me the I value, a voltage, the V total, and the I total, and then R1 and R3. And we're going to calculate together what R2 is. So all of these values give me random numbers for them. Obviously, they need to work out though. So just keep that in mind.
Okay.
7.
6, 7 for voltage. For
Two.
the 2. Okay, wait. Let's not make it 6, 7 rather. Make it 6, 6.
Oh no, such a tough number gone.
It's just because you don't want to end up with fractions. Unless Katishu, you want to do it.
Bro, nah.
Yeah,
You got it.
I thought you could. Yeah,
You got it,
right,
bro.
right. Give me two values for the resistors.
34.
Ohms, and let's put your number here. There. Now we want to know what your resistance 2 is. But first, in order to even start, we need to figure out what on earth's happening here. So we have your I total and your V total. We want to know your R total. What's the formula?
Um, one of RT.
No. we have the V total and the I total, and we want to work out the R total using those two values.
Oh, V over I.
Yes, right?
Goat.
Which means it's 66 over 2, which is then 33 ohms. That's your total. Now, the problem is I don't know if this thing's actually possible, but we'll see now. That's the R total. Right. Now, we want to calculate R2. What do? We already solved the R total, which is 33. What do we do from here, Katishu? Mr.
So,
Zulu, your mic was unmuted, now you give the
bad,
answer.
my bad. So we're
Okay,
gonna find the R2 now.
yes.
Don't you divide by 2?
Were you here when I did the thing is?
Nah, bro. I look at you and late.
Okay. Fine. Let's see who else is on the call. Kian, put your hand down. Yukesh, what do we
Yeah.
do? What do we do here?
Don't you say like R total equals R1 plus R2 plus X?
Plus X. Okay, you close. It's 1 over R total is equal to
Are we
1
doing
over.
series or parallel?
We're doing parallel.
Oh, my bad.
Right.
So isn't
So,
it like
but
1 over
now,
R total?
here's the key thing, right? We don't know what our R2 is. Very complex. Yes, Kian, relax, breathe. You have a question? No,
No, I
okay.
just wanted to ask, would we like substitute in 33?
Yes, under your R
Oh,
total,
okay.
and then which
60.
yes.
Is it 1 over 33 equals 1 over whatever the value is of R1 plus 1 over X plus whatever the values of R3 is?
Okay, so you're on the right track, but just don't use X because it's easier to put R. Well, it's not easier, but it makes more sense to put R2.
Now, but Johnny said I must put an X, and then
Johnny's
it's easy
tweaking.
to calculate like
Okay,
that.
look, obviously it's the same thing. He's talking nonsense because it doesn't matter if you
So
have
what
an
is the
X
X?
or an R2 because you just need to say, okay, then R2 is equal to X at the start.
Okay, bet.
You do you. Whatever's easier for you. Obviously, you just put this in your calculator. However, now the problem is we cannot just invert it because we know our R total. But now the problem is we need to get whatever it is here to 33. So if we say 1 over 34 in your calculator plus 1 over 67, yeah, it's equal to 101 over 2278.
6, 7.
Now your resistor 2 needs to be small enough to actually cancel that out. So this isn't a good example, obviously, because we pull numbers. We use silly numbers and larger numbers, then I did not guarantee it working. But do you see how you would do it? Do you guys understand how you would do it? Or must I do another example with the proper numbers?
Oh,
Excuse me?
I understand it now.
Okay, everyone else?
Where did you get the 227 from?
I just put it in my calculator. Okay, let's go on ChatGPT and ask it for something. Okay, we're just waiting for this thing to give me something easier to work with. Because obviously this is a mess here. There we go. Um, okay, right. Let's see this here. This much. Yeah, the problem. So your first step is paste here. It's the wrong image. There. Right. Here's our question. You got three resistors connected in parallel to a DC power supply. The supply voltage is 12 volts. The current total is 4 amps. You know resistor 6 and you know resistor 1 and resistor 3. Your first step, okay, well, you don't need to know. We won't be given this here. So your first step, obviously R total. Your V over I is equal to R. 12 over 4 is equal to 6 ohms. Just remember to write down your four symbols. Right, 6 ohms is your R total. Now, from there, we need to know what our resistor 2 is. So, what you're going to do is you're going to write down your formula first. In this case, because we have 3 resistors, we only need to write it down 3. We need to only go to 3. Sub in the values that we know. 1 over R total, which is we just solved, which was 6 ohms, is equal to 1 over 6 ohms plus 1 over R2, which we're solving for, plus 1 over 8 ohms. Now, do you guys know what to do from here? You guys, we just did algebra, right? So, well, we did algebra in maths recently. Yeah, well, the marks are not anything to be surprised by, but yeah, anyways, what you're gonna do is we're gonna bring this over here. Wait, I did something wrong. Okay, anyways, whatever. The R is not 6 ohms. Made a mistake here. Okay, I'll see you tomorrow, Yukesh. It's not 6 ohms, it's what? I did not understand that text that you said. Get. Okay, anyways, my mistake there. Anyways, it's 3 ohms. Now what you're gonna do is we're gonna bring this over here and we want to solve for R2. Now, if we bring this over, oh, well, obviously your algebra skills and that, this would be negative because we brought it over. And this 1 over 6 ohms plus 1 over 8 ohms um, minus 1 over 3 ohms. What you're going to do is, yes,
Sorry, I pressed it by mistake.
no problem. So what you're going to do is, obviously you would start cancelling out, get it to a common denominator. 6 times, that's 4 plus 3 minus, let me think, that's now 8. So it's minus 1 over 24 ohms and then we get minus 1 over R2. Now, we don't want minus R2, we want R2. So what do? You times it by negative 1 on both sides. You get R, you get 1 over R2 is equal to 1 over 24 ohms. And when now we don't want 1 over 24, 1 over R2, we want R2. What you're going to do is you're going to flip this. If you flip it, it becomes R2 over 1 and 24 over 1. And anything divided by 1 is still 1. So you get R2 is equal to 24. If I look at ChatGPT, R2 is equal to 24. That's how you do it. Does everyone understand? Okay. Is there anything else
No.
that I may have missed? Okay, that's basically all the calculations. Okay, obviously there is two different methods you could use by finding the amperage across each branch and then doing the resistance from there, but it's not recommended because this method is easier than that one. Yeah, it's fine. I don't mind. Okay, that's everything for the session then. I'll upload the video to the respective platforms and I'll see you guys tomorrow then.
Thank you so much, Brazil.
Obviously, if you go through the video, I'll be online for like
Thank you.
another 5 minutes. If there's any other questions, message me. If I don't get back to you today, I'll get back to you tomorrow in school.
Thank you so much. Thank you.
Okay,
Thank you,
bye.
Big P.
Thank you.
Thank you.
Okay, bye.
Just remember to bring your calculator for me tomorrow, please.
Okay, I will most
See you
definitely remember.
tomorrow.
Okay.